For this question, I want to find equations of all tangent lines to the graph of f of x equals arctangent of x that have a slope of 1/2. So I'm looking for equations of tangent lines, and we know that the slope of the tangent line is the derivative at that particular value, at a particular x value. So in order to start to answer this question, I need to calculate the derivative of my function. I have the function f of x equals arctangent of x, and we have a derivative rule for arctangent that goes as follows. The derivative with respect to x of arctangent of u is u prime over 1 plus u squared. So the derivative of arctan x will be u is our inside, x is our inside. So the derivative of x is 1, so that's 1 over 1 plus, and u is our inside, u squared, that's x squared. So we have the derivative. Now we want equations of tangent lines that have a slope of 1/2. Remember that the slope is equal to the derivative, so I'm going to set my slope of 1/2 equal to the derivative that I just found, 1 over 1 plus x squared. I'm going to solve this equation cross multiplying, so it would give me 1 plus x squared equals 2. Subtract 1 on both sides, and I have x squared equals 1. Take the square root of both sides, and I get x equals plus or minus 1. So this gives me the location of the tangent lines that have a slope of 1/2. So I need to find the equation of the tangent line. To find the equation of the tangent line, I'm going to use point slope form. Y minus y1 equals m times x minus x1. So for this point slope formula, I have the slope. We know that the slope of these points is 1/2. I have the x coordinates, that's plus and minus 1. That's what we're going to put in x1. So I'm still missing one piece of information, and that is the y coordinate of our points. So to get the y coordinates, I'm going to substitute 1 into the function arctangent of x. So I need to find arctan of 1. And I need to find arctan of -1. So I need to think of my unit circle here. And on my unit circle, I know that tangent of an angle is equal to the y over x. And I have arctan of 1. So this means tangent of some angle equals 1. And that's going to happen when the x and y coordinate are equal to each other. The other thing we need to keep in mind here is that in order to have a one-to-one function, we've restricted the domain of our tangent function and restricted the domain of our arctangent function. So we're only looking at angles from negative pi over 2 to pi over 2. So we have here and here where the coordinates of the point are square root of 2 over 2 and square root of 2 over 2. This is going to give me an angle of pi over 4. So arctangent of 1 is pi over 4, because square root of 2 over square root of 2 is 1. Then in this fourth quadrant here, we have the coordinate square root of 2 over 2, negative square root of 2 over 2. So this is going to give us that the arctan of -1 is negative pi over 4. So that gives me the final piece of information to find the equations of the tangent line. So we have now a slope of 1/2. The slope of our tangent line is 1/2 at the point 1 pi over 4. And the slope of the tangent line is 1/2 at the point -1 negative pi over 4. So I'll use the point slope form to write the equation of the line. Y minus pi over 4 equals 1/2 times x minus 1. I'll distribute the 1/2 to get 1/2 x minus 1/2 and add pi over 4 to both sides to get y equals 1/2 x minus 1/2 plus pi over 4. Similarly, using the other information, we have y minus negative pi over 4 equals 1/2 times x minus -1. This is y plus pi over 4 equals 1/2 times x plus 1. Distributing the 1/2, we have y plus 1/4 equals 1/2 x plus 1/2. And we'll subtract pi over 4 on both sides to get the equation y equals 1/2 x plus 1/2 minus pi over 4. So we have these equations. Will give us tangent lines that have a slope of 1/2. Thank you for checking out my videos. Have a great day.